Hello, good morning. So, my name is Marco Cecconi, and I'm going to talk to you about the architecture of Stack Overflow. So, let's start with a question. So it's an easy one, so don't worry, yeah? Who is familiar with Stack Overflow here? Right. So that was too easy, maybe. So who's familiar with the Stack Exchange network, then? Quite a lot of you. OK, let me summarize what it is, because when you do an architecture, the first thing you need to always think about is what kind of problem you're solving, right? So here's what we do. So we are a network of sites, is 110 sites at the moment. They're growing at a rate of maybe 3 or 4 a month. 4 million users, 8 million questions, and 40 million answers. So what we do is we take topics, we create communities around them, and we create awesome question and answer sites. Of course, the most important one and the best known one is Stack Overflow, but we got many different sites, from math to role-playing games to physics, biology, and so on. German. So what does this mean in practice? It means that as a network, we are number 54 in the world and number 7 in Germany, so thank you very much. And what this means in practice, so what does it mean for this, for the architecture of this network, is that we do this. We serve 560 million page views in 30 days. So it's a pretty big task, isn't it? 500 million, that's big. So how many servers do you think we need for this? Maybe 100? Yeah? 50? 200? Can't hear anyone. So these are servers. That's it. So there are 25 servers there. May sound like a lot, but they do a number of things. So this is how we're structured. So we have 11 web servers, of which 2 are special. So in practice, we're using 9 web servers for most of the pages that you see on the site. We have 2 load balancers, only one of which is active. We have 4 active database nodes. We have 3 machines that do this application server thing, which is called a tag engine, which I will explain later. We have 3 machines to do search, and we use Elasticsearch for that. And we have 2 or 3, depending on the day, almost. we have two servers for Redis, which is our distributed cache and messaging system. So that's all that there is to it. So what all do all these components do, right? So here it is. This is our homepage. As you can see on the top left, there is that Stack Exchange drop-down. Do you guys know what it is? It's called the Supercollider, and basically it's like a message box. So every time you gain a badge, or every time you receive a message, or if there is any significant event, there will be a message popping up there. That is done using WebSockets, which is powered by Redis. The top right, you can see the search, which, as I was saying, is powered by Elasticsearch, which is basically a search engine in a box. You just put in nodes, they index your site, and you pass a query via REST and get the stuff back, get the results back. And then there are favorite tags, which are used to generate this interesting tab over here. So the interesting tab is a concept that we put in because we got so many questions on Stack Overflow that we couldn't simply put the newest questions in this home page because they would change so fast. Basically, we get a question every less than a second or something like that. So what we do is we created an algorithm that looks at your pattern of answering questions or looking at questions, and looks at your favorite, explicitly set favorite tags, and it tries to generate a set of questions that you are more likely to be interested in answering. That requires some very complicated queries on top of tags, so questions by tag. That's why we have a tag engine, which is a specialized system that does this kind of things for us. So next, so we have 25 servers, right? But our servers are not tapped. They are not doing much. As you can see on the top left, those are our DB servers. Only the NY and the New York servers are actually in any form active. The other ones are just spares. As you can see, they are maybe around 10%, apart from 2. The ones that are on 2 is because they were taking a backup while I took the screenshot. And so we are basically on 2 servers with a read-only copy. The reason we can do this is, if you look at our memory, it's 384 gigs of RAM, which is like big. That helps, and I will explain that later. Another thing is the web servers. They're all around 10, 15% usage. So what this means that if we wanted to, we have calculated, and obviously it's a calculation, we don't normally try this kind of things, but we could run on 5 servers only. And that's a lot, or is very good, in my opinion. So yes, scale out after you scale up, and we're still scaling up. 5 years in, we're top 100, almost top 50 network in the world, and we're still scaling up. Our competitors, or not competitors, but other sites of the same size, the same number of page view, they tend to run on 100, 200, 300 servers. And we could run on 5. So why is that? And how do we achieve this? And why? How? Here we are. So first of all, we have a very simple system. So we are built on top of .NET. Are you guys familiar with .NET? Who's familiar with .NET? Not many. OK, but it's fine. So this is not going to be that technical. So there are solutions, and solutions contain projects, and projects contain classes, right? So we just have 9 projects, which means very few. Normal or a common size for many projects. And many solutions that I've seen is maybe can reach 100 projects, just to keep it to 9. The reason we do this is that we want compilation to be lightning fast. So being fast starts at the beginning, the basics. Your compilation should be fast. And at the moment, we compile maybe in 9 seconds or 13 seconds on this computer here, which is MacBook Air, not really a development computer. Other things, lines of code, that counts. We have 110,000 lines of code, so a small project considering all it does. So all this efficiency, though, comes with a few caveats and a few problems, and one of them is this one. We don't have many tests. So I'm not advocating that you shouldn't put in tests, but there are reasons why we are doing this, and there are reasons why we can do this. And the most important reasons why we can do it is this one. We have a great community. So basically, I was saying that 2 servers are special. Do you remember that? These 2 servers contain a version of a site or a different site, which is called meta.stackoverflow. Do you guys know what I'm talking about? Probably not, only a few know about it. So what this site is is a site where people go and discuss our network. So the topic of the site is the network. The topic of the site is Stack Overflow. And it's also a place where people go and report bugs. And it's also a place where the community lives and thrives. So what happens there is that we put only on this site, we deploy the newest versions, and then the community basically tries it out for us, and they publish bugs if they find any bugs, and sometimes they actually post solutions. So we even get patches or bug fixes directly. So that's great. Great for us, for developers, of course. So basically, instead of having automated tests, we have an automated humans testing the site. So that's great. So the meaning of this is the way we build this stuff is we started with the simplest possible thing that could work. Right? We had the community, we used that. We didn't add tests because we needed to, or because someone said that. We just do what we need to do. We add projects only when we need to. We add a line of code only when we need to, and so on. Yeah, so it's Yagni, right? You ain't gonna need it. It works. So this I advise to everyone to use. Please use it. This principle is very important. Another thing I'm gonna talk about is exactly how this works. So as a developer, as I was saying, compilation is the first step and needs to be fast. Right? So that's the first step. That's the first feedback loop. Feedback loops are very important for us, right? So the first thing is the bat cave. The bat cave is like our remote offices. Everybody works from home, so I work from an office in my place, and it's called the bat cave. Sorry if it's a spider there. I couldn't find the bat thing, and there was just a spider, and so don't mind. And I don't use a Spectrum. I used to use a Spectrum like when I was a kid, but now I actually have a real computer. Anyway, so you code there, you develop there, you test there with the few tests that we have. You try it out manually, see if everything works. And that happens obviously very fast, and we make sure that even compilations run fast and everything. Once that is done, it's compiled, and as most development teams, we have a shared server. The only particular thing about our shared server is that it's a publicly sort of password-protected site. So for most other teams, as a setup would correspond probably more to a staging server. But that is, we call it dev. In it, you can see the latest version. For example, the top bar is different from the previous screenshot because it's a new feature that we are building out. We are deploying live next week. So in there, we have typically the latest version. The new things are hidden via feature switches. And that's it. That's very realistic. It runs on real hardware. It runs on most of it runs on the same hardware as the rest of the sites. So that's another important feedback loop. Feedback loop. Next, as I was saying, Meta Stack Overflow. So we have a live site with live people, and there are more than 1,000 active users every day on that site. So it's not that small. And we put stuff there that's a real live thing, so bug fixes come in from this point on. So for example, in this case, there were problems, right? We deployed and we had some post-processor that went wonky, and the site went out without any headers, so no JavaScript, no CSS. But as I was saying, our users are awesome, and this guy actually managed a way to post a bug fix even though the site was down. I don't know how he did it, but yeah. So assuming that this doesn't happen, yeah, we don't go back to the back cave like in panic and say, oh God, fix it, fix it. So we go live to the network. And in here, instead, we get a larger part, a larger set of testing by the real community. So the larger community. So for example, we get feature requests coming from the network that we normally don't get for new versions of Meta. So, motto, move fast and break things. Don't think too hard. And, put stuff live. That's the best way of testing for us. Of course, don't break the homepage. If that happens, really is panic, obviously. So it happens sometimes, but not to me, because I'm lucky, maybe. So why do we do this? Because we want this. Yeah, we want to deploy 5 times a day, and we do deploy 5 times a day. So today, we have deployed twice already. So that happens a lot, and that's very important. We have always a live system. We don't build grand, gigantic things and then put them live. They're put live instantly. That's very important because we can measure performance, for example. Directly, we are forced to build the smallest possible things that would work. We don't just spin off for 2 months and then bring something in. That's over-engineering, this over-architecture. We don't do that. Another thing which is really, really important for post speed is caching. You know what caching is, right? So this is how our caching works. So we have 5 levels of caches. So the first one, 4 levels. The first level is the obvious network level caches. So your browser's cache, our CDN, content delivery network, proxies, and so on. That's really like almost every other site, so nothing great there. Then we have some caches, one cache which is given for free by the .NET framework, which is called HTTP runtime.cache. So this is an in-memory cache that runs per server. Each server has got its own copy of the objects in that cache. The next level of caching is Redis. So Redis is a distributed cache. It's an in-memory key store, key value store. What this does for us is that we can share cache elements across different servers which serve the same site. So Stack Overflow runs on 9 servers. If one of these 9 servers has accessed a particular page, all the other servers can find it in the Redis cache. On top of that, or behind that, we have a database cache, or a large amount of memory that SQL Server is using to cache basically the whole database. So the whole database is actually cached in memory of the database. That's why we have 384 gigs of RAM. That is enough to hold all our data in memory. And if a query has never been made before, because maybe, I don't know, we restarted SQL Server or something, then only then the solid state disk is hit. So there's basically nothing physical apart from RAM being hit in 99.999% of the cases. And that's very, very important if you want speed. So how does this work? So how do we, each level of caching you put in, it's more work, right? It's more complexity, it's more levels, it's more indirection, it's more classes, right? So not really. So this is the help center. I don't know if you're familiar with it. It's our help system, basically. You can access it by going to stackoverflow.com/help, and it contains basically a CMS. It's like a multilingual, multi-site CMS, which has pages about our policies or help for users. What do I do if I want to erase my account, or what is the bounty, and so on. So every one of these pages, every one of these help pages is cached, obviously, as I was saying before, right? And it's going through those 4 levels of cache plus the network one. And, okay, let me show you the code to actually generate a page or to get the data from a page. So this is the code. It's 10 lines of code. That's all that there is to it. It's very, very terse. And the reason why it's so terse, there are multiple reasons. The first reason is that we use static methods and static classes. These are really bad from an object orientation point of view, and people discourage using them. However, they're really fast, and they're really friendly to terse code. So that's the reason we use them, and that's one of the reasons why we can test so little, because everything is not deferred, it's just straight, directly addressed. Another thing is, we have two libraries here. One is an internal library. It's called Stack Redis, which is built on top of other libraries which we have open source. And that's the get set line on line 208. So what that does is that all the caching in one line, basically. And the other libraries that's being used here is on line 214, which is Dapper. And Dapper is our micro ORM. And that's all that there is, to access the DB, is just that line, basically. What it does is runs the query and creates a set of help post objects already filled with the data. So the code is very terse, and this is a classic example of caching. So this is the simplest way we cache. Other things, though, so this is our most popular answers, if not our most popular answer. And Tony the Pony and stuff. Anyways, those top 3 tabs, right? What do? They just sort the answers. They don't do anything. From the point of view of the UI, they are simply 3 anchors with a title. And that's it. That's all that there is to it, okay? It's a very simple HTML thing. So the way we built those is by creating a component that generates the HTML, and you pass to that component, you pass classes, and these classes have the title and the URL and the link, right? So it's very simple. There is no logic in it. It's just pure templating. Unfortunately, things are not so simple in the world of high performance. So what we do is, yes, we create the 3 classes and pass it to the template engine. However, those 3 classes, which take literally nanoseconds or microseconds to be created, we still need to cache them. Does anybody have an idea why we're caching them if they are so fast? No? Do you guys know what garbage collection is? No, it's a serious thing. So garbage collection is the magic. There's a magic virtual machine running behind the scenes that when you create objects and you make sure that it throws them away once you're finished. The problem with this machine is that at times it needs to actually clear away stuff, and it takes time. And it actually takes a lot of time if you have a lot of garbage to put out. So the problem is that if we just create classes all the time on our most viewed pages, we create too much garbage, and it takes a long time for that machine to clean all that garbage away. Even though it's almost instantaneous to create them, eventually it takes much longer to clear all of them. So we need to cache them. So we create only 1 copy of those classes, and we just reuse it for every page. And this is tricky. This wasn't easy to find out. So, important things. Cache all the things. Yeah, it's a very important principle. Another thing is, another principle that we use, you have seen bits of it in what I've just did, is this. So, do you know about square wheels? Anyone? Can you raise your hand if you do? Nobody knows about square wheels. So, square wheels is an anti-pattern. So, it's something that you should never do according to Wikipedia. So, do not reinvent a library which is already out there. Don't make your own, because you're going to make it worse. You're not going to reinvent the wheel. You're inventing the wheel worse, square. Yeah, so when people say reinventing the square wheel, they think about this. Yeah? Sad kid on broken tricycle. When we say, as Stack Overflow, when we say we reinvent the square wheel, we actually think of this. Yeah, so this guy is called Stan Wagon, and is a mathematician a long time ago, in 1960. He calculated that if you were to run on a really bumpy road, which is basically made of catenaries, actually if you had square wheels, it would be better. Yeah, so it's a relative concept, right? So sometimes you need to build your own square wheels. And we build a lot of square wheels. Yeah, these are a few of them. These are all open source projects. And we built them as part of Stack Overflow. We package them and release them as open source, as a practice. We do that constantly. That is very important, and that is one of the reasons why you see the code, which is so simple, because the complicated bits are packaged away in a library, we make it open source, we ship it, we can't change it anymore, so we make sure we make it right and we maintain it. And that's it, and then we use it. So the number of projects stay low because we use community-owned parts of the code. Yeah, it's like our code becomes smaller and smaller because we give most of it away, and our code becomes something which puts everything together. So reinventing the square wheel is very important. This is also important because, for example, Dapper.net is our ORM, and it's basically 10, 20 times faster than any other commercial ORM like Entity Framework or Link to SQL and so on. It's very, very fast. It uses really ninja tricks to be as fast as handcrafted code. Everything that we build is like built specifically to be fast, to be high performance, to be simple to use. And that's why we do these things. It's not because we don't like other libraries. We use them. We use other components when they're what we need. We use Redis. We use Elasticsearch, for example. Yeah. So morale of the story is, reinvent the square wheel and open source all the wheels and do that. Other things. So in conclusion, a few principles. We can do all these things, and we can do all these things this way because we have a great team. This is my team. As you can see, we get t-shirts for free. And actually, most of these are not developers. In this picture, only 5 people actually do Stack Overflow. Everybody else does either our career site, or is a graphic designer, or product manager, or community manager. These are the people you interact with on the site anyways, but there are 5 people building this. And so how can you make an awesome team? So what are the kind of things we do differently from other teams? So the first thing is we love geeks. So do you guys know who these people are? Yeah, so it's Microsoft, right? Bottom left is Bill Gates, bottom right is Paul Allen. They were a geek company at that time. And, they conquered the world, so yeah. There's no Balmer, I think, in this picture. Other principle, down to the metal. So, yeah, you get great abstractions nowadays, right? So you got your nifty library that's, does everything for you, and you just press a button and add a few lines of code, and there you go, new Facebook, right? Not quite. And the reason why it's so complicated is because these are abstractions, and abstractions become leaky after a while. And we go down and go beyond those abstractions all the time. So we look at how our code is generated. And this is on the left, you can see IL. And IL is like the assembly language of .NET. And we definitely do stuff in that language, which is not even C#, is very low level. when we do SQL queries, we look at query plans all the time, and we actually have a system by which we can remotely see the query plans that are being run on the server. Another thing that, that we do is we take memory dumps of the web servers and see what actually is going on. You know, what is using the memory? Oh, we just discovered, for example, last week, we discovered that there is an attribute, there's a small piece of code by Microsoft which does a split of a string, and that generates too many strings. So we have, again, too many objects, and we actually had 2 gigabytes of strings, all the same, gzip, semicolon, something. So yes, we do look at the memory dumps, we try to understand what's wrong and how to fix it. Other stuff, how do you hire people? Our CEO has literally written the book on hiring developers. It's called Joel Spolsky. He's had a blog for a very long time. This article is from 2006, but he's been blogging for, I think, 5 years longer than that. So we have selective interviews, but we hire from our community. So we don't have a corporate environment. We have, basically, you take the Stack Overflow community, you take a subset of the people, maybe with high rep, put them together in a room, and that's it. That's how we build our company. So people with a passion, we share a passion for helping others, passion for communicating, and passion for coding. Another thing, tools. So the bat cave. So this is not my bat cave, someone else's, but I did find a symbol eventually. So tools, right? So as developers, we need tools, right? We need to have a nice computer with 2 screens, 3 screens. A lot of people are stuck with just 1 screen. It's ridiculous. No, screens are important. They help you being productive, right? Tools like, I don't know, the proper version of Visual Studio, or your favorite editor, or some refactoring tools, or database access things, or whatever you need. There is always something that your team needs and your developer need. The problem is that many companies, what they do is they put bureaucracy in front of you, right? So a company I work for, I just needed a copy of ReSharper, which, if you know .NET, is like a basic tool that everybody uses, or most people use. Took them maybe 3 months to get me a copy. So in those 3 months, I wasted so much time that I could have saved and would have paid for the tool over. And so no bureaucracy. In a Stack Exchange, I've asked for ReSharper like the day 1 I started working, and by the end of the day, I already had a license. So yeah, no bureaucracy. And that's pretty much, that's it. The last thing I want to say before questions is this one. We strongly believe that people should give back to the community. This is documented by us donating our code to open source. All our content are freely available in CC Wiki, and we try to give back to the community in every way possible. And we encourage that you do so the same. And it's very, very important that your team feels, that they're doing something valuable, and they're doing something valuable for someone else. So that's it. Thank you very much.
Okay, thanks a lot, Marco. So we have probably 10 minutes or 15 minutes for questions. So if anyone had a question, just make hand signs. So, okay, one over there. Daniela, kannst du mal da hinten.
First, thank you, Marco, for a very good presentation.
Thank you.
I think you very well explained your architecture and how you're using your servers and all these kinds of things.
Yep.
But you not really explain, and you also mentioned a lot that you are making use of the open source community.
Yes.
And back and forth. But you did not really explain how you come across of Microsoft and why you're using Microsoft as all. And that would be, is this by accident or by purpose, or maybe you can explain this a little bit to us.
Okay, you have to understand, first of all, the first thing is languages are not that important, okay? Not that important. Facebook was written in PHP, right? So there is a lot of, you know, if I use Node.js, I'm going to be great. The answer is probably you would be great anyways, or you would suck anyways. You know, languages are tools, right? So we don't really, are not a Microsoft shop. We do use C#, we do use SQL Server, but we use HA proxy, we use Redis, we use Elasticsearch, all of which are non-Microsoft technologies. They don't even run on Windows. The reason why we originally chose this is because there was a program called BizSpark, and basically they gave us all this stuff for free. And to be honest, at the time, our co-founders were Microsoft developers. That was the main area of expertise. So it was low risk for them. And I think that .NET is a very fast platform. So it suits the style of coding that we do. If we didn't, we would just drop it very easily. Well, not easily, but we would make the decision to drop it.
I have a question regarding Dapper.
Yes.
So before you wrote Dapper, did you use plain data reader, or did you use something like Entity Framework and were disappointed?
So when we built the first version, there was no Entity Framework. It was linked to SQL, and it's linked to SQL. It's terrible. So we still have some link to SQL queries, and we were just investigating a few today because they are incredible in their own way.
Hi, thank you for the talk. I want to know if you have any separation between the different sites, or are the app server exactly the same and you just have like one, you check the host name, which is it?
It's a bit more complicated than that.
Okay.
So on the web server level, we are completely multi-tenant. So each web server serves all the sites. However, the databases are separate per site. So at the moment, we have 110 sites, and we have 220 databases. On top of that, we have one database which contains all the connection strings and the network data, if you like. Then there are the load balancers, which decides, based on the host names, which web server is hit. So that's how we can have two web servers that only run one site. They actually could run the whole network, but only requests for one site go there. Okay?
Just one quick question more. Yeah. If you do an upgrade, you upgrade everything, or you may have different versions for the different sites, or different subsites?
So yes, so deployment is made per web server. So that's the unit of deployment. Typically, we do a deployment on Meta, which means we go on New York Web 10 and 11, and we push a new version on those web servers. And then we let it, we say bake in there, so we let it live there for some time. And after that, we deploy to the other 9 nodes. It's just one click, it takes 5 minutes.
Okay. Thanks for the talk.
Yeah,
I was quite impressed that your code base is just around 100K of lines.
Yeah.
And can you give an estimate of
the lines of code externalized in open source projects?
I have no clue. But they don't really count, though, from the point of view of complexity, right? So if you build a site today and you use Dapper, do you count the lines of Dapper?
No, it's just to get an idea how much of intellectual property you give away for free.
So we don't know yet. Yes, a good question. I don't know. The short answer is as much as possible. We don't care about retaining any intellectual property on our code.
So any further questions?
There's one.
Another question, when you started, you showed, I think it was the first or the second slide,
Yeah.
that your database servers has quite a lot of memory.
Yes.
And then later maybe I've missed this, but can you say some more words about this?
Yeah, sure. So the reason for this is that databases are built so they try to keep as much data as possible in memory. And the reason for this is that it's obviously faster, right? So instead of going to read to the disk, they just read from an array that they have in memory of rows. And if you give them enough memory, eventually they will cache all your data in memory. So when you, at least SQL Server, but I've used MySQL and other servers, and they tend to have the same kind of behavior. So when you start up a database server, it will just look at the system memory and say, okay, give it all to me, all of it. Yeah. So if you look at them, ouch, this is gone. Maybe I can do it this way. So, hang on a sec, sorry. Here we are. So, as you can see, they have 384 gigs of RAM, but on the right, the memory is all used. Yeah, that big, fat, blue bar. The reason for that is that, that memory is there for a reason. It's being used as cache. So all the data is just pumped in. Yeah, so they serve your queries from memory. Does that answer your question?
I wonder, do you have distributed processes talking to each other through something like .NET Remoting or WCF, or do you just don't need this overhead?
No, yes, we do need it, and it depends, right? So in this image, you can see that. So if we go to Elasticsearch, it's got the REST interface, so it's HTTP. We tend to prefer protobuf. Protocol buffers is a Google technology, and we created the .NET client for that. It's a very, very fast serialization protocol. So we use that for Redis, and we use that for Tag Engine instead of any form of WCF or things like that, which are fat and slow.
Okay, thank you.
Yeah.
If there's a last question.
I've got one question about your TDD utilization.
Yeah.
Stack Overflow is a very huge, successful site, and you said you are using no TDD.
Yeah.
What is the reason for that?
So we use fear-driven development. So we are afraid to break the site, so we're cautious. No, the reason for that is that TDD tends to generate very verbose code in a way. So you write a test, but then you need to separate concern, you need to use inversion of control, and so on and so on. You can't really use static stuff. It gets complicated. And we create too many classes. So serving 500 million pages, even though it's through 9 or 11 servers, still creates a lot of instances, and then garbage collector is not happy at all. And I'm not talking about something that, problems that happen maybe once a day. If we create too many classes, what happens is that maybe every 20 seconds we have a collection happening, and then everything stops for a few seconds. So you're browsing the site, and then, okay, here's a page. So that's just not acceptable. So we can't do that. The other option, if we wanted to do TDD, inversion of control, dependency injection, and so on, we could do that by splitting the requests over many more servers. So we could have maybe 50 web servers or 100 web servers. Then we wouldn't have problems with garbage collection, and then we could do that. But what's the point?
Okay, Marcos, thanks a lot.
Thank you very much.
Soweit sind wir jetzt erstmal zum ersten Break sozusagen bereit. Also es ist jetzt 12 Uhr, dementsprechend ist draußen der Mittagstisch aufgereiht. Ihr könnt jetzt zum Essen gehen. Um 12:20 Uhr, glaube ich, gibt es hier im großen Saal so eine kleine Fragestunde an das Organisationsteam. Richtet sich eigentlich vor allem so an Bloggern und so weiter, aber wenn auch andere Interessierte Fragen stellen möchten zur Organisation der Konferenz etc., habt ihr da die Möglichkeit, dort mal ein paar Punkte herauszuquetschen. Soweit wünsche ich euch allen einen guten Appetit und wir sehen uns dann ansonsten um 13 Uhr wieder hier. Dankeschön.
Focus on what you say, but I think there are many questions. That was good. So